Namaste. Today in this video we have some simple trigonometric identities. These trigonometric identities are taken from SPD Additional Mathematics of grade 8, but these identities are equally important for grade 9 also. So let's see how to solve these trigonometric identities. First one is x cos A plus y sin A whole square plus x sin A minus y cos A whole square equal to x square plus y square. Let's take its LHS left hand side. LHS is x cos A plus y sin A whole square plus x sin A minus y cos A whole square. First one is like A plus B whole square. You can consider x cos A as A and y cos A as B, and it will look like A plus B whole square, and we'll apply the formula of A plus B whole square. That is formula of A plus B whole square equal to A square plus 2AB plus B square. That means if you say A as first term and B as second term, it will look like first term square plus 2 into first term into second term plus second term square. Here also we must write same pattern of formula. The square of first term, here first term is x cos A, so we'll write x cos A whole square of first term plus, then after 2 into first term into second term. 2 first term is x cos A, second term is y sin A. Then second term is square. Here second term is y sin A, and we'll put square of y sin A. And in second term also we'll consider x sin A as A and y cos A as B, and it looks like A minus B whole square. We'll apply the formula of A minus B whole square, and we'll get x sin A square minus 2 into x sin A into y cos A plus y cos A square. Now we are comparing this term and this term. This term is negative, this term is positive. Here also we have 2, here also we have 2. Here we have x cos A, y sin A. These two terms are same, but they have different signs, so these two terms can be cancelled over here. Now write down the remaining terms. Here we'll get x square cos square A, x square cos square A, and this is y square sin square A, and this is x square sin square A, x square sin square A, and this is y square cos square A, because this is square of y also, cos also. This is square of x also, cos also. Similarly, this is square of y also, sin also. This is square of x also, sin also. So finally here we'll get y square cos square A. Since we have to prove x square plus y square in right hand side, we'll check the terms with x square together and y square together. We'll write x square cos square A plus x square sin square A. We'll write together. Similarly, y square sin square A plus y square cos square A will be together. Then from these first two terms, x square is common, and there will remain cos square A plus sin square A. And from these last two terms also something is common, that is y square is common. There will remain sin square A, and here will remain cos square A. Again, we know formula of sin square A plus cos square A is 1. We know this formula. Sin square A plus cos square A equal to 1. So in place of sin square A plus cos square A or cos square A plus sin square A, we'll put 1. And here we'll get x square into 1 plus y square into 1 equal to x square plus y square, which is our required RHS. Hence it is proved. Let's see the next question. That is, prove that 1 plus 10a whole square plus 1 minus 10a whole square equal to 2 sec square a. Here also we'll take LHS. LHS is 1 plus 10a whole square plus 1 minus 10a whole square. Here we'll consider 1 as a and 10a as b. So it will look like a plus b. Use the formula of a plus b whole square, same as above. We'll get 1 square, square of 1 is 1 only. 1 square plus 2 into 1 into 10, but 2 into 1 is 2 only. 10a plus 10 square a square plus 2ab plus b square. That means 10 square a. And similarly here also we'll apply formula of a minus b whole square. We'll get 1 square minus 2 into 1 into 10. 2 into 1, 2 only. 10a plus a square minus 2ab plus b square. B square means second term square, that is 10 square a. And this is equal to, now minus 210a and plus 210a are cancelled. Then here remain 1 plus 10 square a, 1 plus 10 square a. 1 plus 10 square a plus 1 plus 10 square a. And we know one more formula, that is 1 plus 10 square a equal to sec square a. So in place of 1 plus 10 square a, we'll write sec square a. And here also 1 plus 10 square a is also sec square a. Sec square a plus sec square a equal to 2 sec square a. And this is our required RHS. Hence proved. Okay, next, C number. There is 1 minus 10a, 1 minus sin a minus cos a whole square equal to 2, 1 minus sin a, 1 minus cos a. Before starting this, let's discuss on some formula. Suppose there is a plus b plus c whole square. A plus b whole square, a plus b plus c whole square equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca or ac. And if one of them is minus, a minus b plus c suppose, then all of the terms with square are positive only, because square of negative is also minus into minus becomes plus. All of the squares are positive, same as previous, a square plus b square plus c square. Then here is 2ab. We have to take the term with ab. A is positive, b is negative. Plus into minus becomes minus, so it will be minus 2ab. Then term with bc. B is negative, c is positive. Minus into plus becomes again minus. It will be minus 2bc. And finally we have to write the term with ca. Here a also positive, c also positive. Plus into plus, plus 2c. And in terms of b, if c is negative, a plus b minus c. If c is negative, then our formula will be a square plus b square plus c square, all positive. Then we have to write the term with ab, where a is positive, b is also positive. Plus into plus, plus 2ab. Then we have to write the term with bc. Here b is positive but c is negative. Plus into minus, minus, minus 2bc. And at last we have to write the term with ca or ac. Here a is positive, c is negative, so it will be minus 2c. And now we need the formula of a minus b minus c whole square. A minus b minus c whole square. This is equal to, all of the square terms are positive only, same as previous. Then We have to write the term with AB. Here A is positive, B is negative, it will be minus 2AB. Then term with BC. Here B also negative, C also negative, minus into minus becomes plus 2BC. And finally, we have to write the term with CA. Here A is negative, C is positive, A is positive, C is negative, so it will be negative. Minus into plus, minus 2CA. Here we need fourth formula. Let us take LCM, LHS at first. LHS is 1 minus sin A minus cos A whole square equal to, we'll apply this fourth formula. We'll get 1 square is 1 only, plus sin square A plus cos square A. These three terms are like A square plus B square plus C square. Then minus 2AB, minus 2 into 1, 2 only, sin A, minus 2AB. Then plus 2BC, plus 2B means second term, C means third term, sin cos. Second term is sin A, third term is cos A. And finally minus 2CA, minus 2 CA. C means third term, A means first term. Cos A into 1, cos A only. Now we know sin square A plus cos square A equal to 1. So we'll get 1 plus 1 minus, write other everything same, 2 sin A plus 2 sin A into cos A minus 2 cos A. And this is equal to, this is 2 minus 2 sin A plus 2 sin A cos A minus 2 cos A. Now let's see the RHS. What do we need? We need 2 as common in all. Is there 2 common in all? Yes. 2 is in first term, second term, third term, and fourth term. Let's take 2 common. After taking 2 common, we will have there, after taking 2 common, there will remain 1 minus 2 is taken common, other everything is as it is there. Okay, inside the bracket, if we take 1 common from first these 2 terms, 1 will come outside, and there will remain 1 minus sin A. And from these 2 terms, if we take cos A plus cos A common, there will remain sin A minus 1, but we need 1 minus sin A. So terms need to be arranged. First of all, we'll arrange the terms. This is equal to 2 1 minus sin A. We'll take minus sin A before sin A plus cos A. We'll take the minus cos A before sin A minus cos A, and we'll get minus cos A plus 2 sin A into cos A. Now 2 is common already, and from these first 2 terms we'll take 1 common, and there will remain 1 minus sin A only, because after taking 1 common nothing will be changed. Minus cos A common, in place of cos A there will remain 1, and after taking minus common, this plus also will be changed, because in place of this plus there is minus into minus. One of the minus is already taken common, in place of that plus there will remain minus only. Cos A is taken common. 2 is already taken common. Wait, here was not that 2. 2 was taken common. Sorry for that. Okay, 1 is remaining in place of this because cos A into 1 is cos A. After that, if minus is taken common, in place of this plus also there will remain minus, and that is sin A remaining. Inside bracket there are two terms. This is one and this is another. And in both of the terms, 1 minus sin A is again common. We'll take 1 minus sin A common. 1 minus sin A is again common, and there will remain 1 and minus cos A. In another bracket, 1 minus cos A in another bracket. This is our required RHS.